You want to state your name for the record?
Yeah, my name is Pat Kaufman.
And what is it you would say that you do? What is your job?
I'm a tube amp repair technician,
Uh huh. And where do you work?
primarily out of Main Drag Music in Brooklyn.
Uh huh.
And right now I'm in my personal shop in my home.
Cool. And the reason I wanted to have you on is I'm kind of doing this survey of all the different ways that people can make a living in this crazy kind of tangential to music related industry stuff. And
Mhm.
the world of amps and electronics has always mystified me. Like I can bang out a Strat wiring diagram if I need to, but I don't really fully understand what's going on. And I thought it'd be really good to get you on to maybe kind of get me hip to some of the things that go on with electrons, but also to kind of find out what your day to day experience in the shop is like, and kind of what your life looks like as a amp repair guy.
Yeah,
So
sure.
um, I thought it would be interesting to kind of go over a circuit,
Hmm.
and you do have a circuit kind of printed out, and
Yeah.
you want to go over that really quick and kind of tell me like from
Yeah.
from when the electrons come out of the wall to when a racket comes out of the speaker, kind of what's
Yeah,
going
sure.
on.
Let me let's do I have a couple schematics here. Let's do the Supro Thunderbolt because I have one on the bench over there. So we can go reference the amp in a second. I'll tell you what, why don't I move out of radio land and move into audio land?
Okay.
So I'm just gonna make my 20 steps over here. And yeah, this is my radio shack because most of my repairs, are through Main Dragon Audio down in the city. The few repairs I do up here tend to be radio repairs.
Oh, cool.
So I'm a little bit light on audio stuff here and very heavy on radio stuff.
So when you say radio, are you talking like grandma and grandpa's old kind of radio, or what kind of radio are you talking about?
Yeah, I'll show you. Well, I have an amateur radio station and I have a collection of antique radios. And watch this here. Let's see. All right, so
Oh,
real
wow.
quick, this is the amateur station.
Oh, so that's ham radio.
Yeah,
Oh, cool. So is that are those all individual different radios, or is that
yeah, yeah.
so how do
This
you so do you wire them together to get a better signal, or how does it work? Or is this just kind of a collection of radios?
Well, yeah, it's a good question. It's old school, so a lot of the transmitters and receivers are separates. So they're kind of wired together, so I could transmit on one frequency, and then it switches over to the receiver when I'm listening. Um, and that's kind of what's happened here. I built this. That's called a modulator.
Uh huh.
Um, but yeah, I have an affinity for vintage stuff, and that's just my bag. So
Okay.
these are just regular old AM broadcast. I've been collecting these since I was a kid. I think like this one, I was probably like 7 years old when I got that one. So the bug started young, and once I became a rebellious teenager and picked up the guitar, well, I was like, well, I'm just gonna fix tube amps because I love messing around with tubes.
So you were
And
already you were already halfway there just because of your love of radio.
these are my tubes, some of my tubes. As you can see, with audio, most of the tubes that you need are still manufactured, but the radio tubes are not manufactured. So I have quite a collection. I kind of did a big score at an auction,
What
and
yeah, what does it take to keep yourself in the tubes that you need then? Is it so that is a finite resource at this point then is what you're saying is the to
yeah,
keep your radios going, that's not those aren't tubes that are coming back?
they're not coming back, and there's not that many people in the hobby. So for radio tubes, most of them are pretty affordable, and you can get old, rare audio tubes are very expensive. and good luck, being able to afford them. I certainly can't, to be quite honest with you. A vintage 12AX7 right now, NOS, could be like $150. Um, so for most audio repairs, we're using newly manufactured vacuum tubes.
Kind of the fetishization of tone, like everybody, automatically thinks old stuff is better. Is that true to any extent in the
Yeah,
in the world?
and some is true. It's tone subjective, so everyone's taste is different. But in terms of quality, the older stuff definitely is more high quality. But that doesn't mean I recommend people go out and buy vintage tubes. Most of the ones in the market are just rejects from back in the day, have problems, So to pay a premium for vintage tubes for your, twin that you tour with might not really make a lot of sense.
Yeah.
The newly manufactured stuff is fine. It's good. It's reliable. Yeah, if you compare it to a vintage tube from, primo quality, military grade, yeah, it might. The new stuff maybe won't sound as good, but
Uh-huh.
it's subjective too. It's subjective. See
Well,
if I can
I
get it.
know that people like to, they like old stuff just because it's, like it's harder to get, and maybe they think there's a premium. So it's always
Right.
going to color every opinion.
Yeah, just because it's expensive doesn't mean it's better.
Uh-huh.
All right.
I have that conversation quite a bit at home.
Yeah. So you know what I'm gonna do? So we can look at this amp in the schematic.
Okay.
I'm gonna do. All right, that's probably better.
Oh
Um,
yeah. Oh yeah.
good, good. All right, so I tell you what, let's start with the amp, and then we'll look at the amp, and then we'll reference the schematic. We can go through everything from the power supply, the input to the output.
Okay.
All right, so here's a 66 Thunderbolt, Supro Thunderbolt here.
Mm-hmm.
Hopefully the lighting's okay. I kind of had a difficult time. As soon as I turn on the shop lights, it like washes everything out. So it's actually really dark in here. So I don't know if you're able to see. Okay.
It's pretty good.
Good, good. All right. So yeah, let this warm up and put in our input. And there you go. That is sine wave. So when you're troubleshooting amps, you always need a clean sine wave. And you put in your clean sine wave in your input where your guitar cable will go,
Uh-huh.
and we're monitoring the output. So instead of a speaker, we'd be blasting volume right now, it's going up to my test equipment into a dummy load. So we don't hear anything, but we can monitor it right here on the oscilloscope.
Oh, okay.
And that's a nice clean sine wave. And then as I increase the volume, you see distortion, which is what you want in a tube amp. If you're going for a distorted sound, there you go. And let me see if I can clean this up a bit. If lower it, let's do this.
So you're sending a signal into the amp, and then the amp is going through the dummy load into the oscilloscope, and then you're measuring, instead of listening to what the amp is doing, you're getting a visual representation of what the amp is doing. Is that
Exactly,
fair?
exactly. And this way I can know if it's generally working okay, right off the bat. So
what are some things that you would see on the oscilloscope that would give you pause and think there's a diagnosis to be made?
yeah, severe distortion would be one. If I pull a power tube, we might actually, yeah. So now you're running on one tube, and you can tell it's really distorted.
Oh
So
wow.
if I saw that, I could know right away, okay, you probably have a bad power tube, or there's something going on in the phase inverter. Yeah, so you're looking for, there's definitely clues. And
So the way that wave becomes square at the top, is that what you're calling distortion, or is it just doing that because of the resolution on the oscilloscope?
that's definitely a distortion. And in a tube amp, and I'm trying to get it here as I bring it up slowly, that's soft clipping. That's kind of where the magic is with vacuum tubes.
Uh-huh.
With solid state equipment, it just starts clipping very harsh and very fast. where in a tube amp, it's kind of gradual.
Okay.
And a good sounding tube amp, it kind of like rings like a bell.
Uh-huh.
So if you're playing, like, this could easily just be a guitar signal, but as you start laying into it, you get that soft clipping and you get that distortion.
Uh-huh.
And then when it distorts with tubes, you tend to get really nice, like even order harmonics,
Okay.
as opposed to odd harmonics, which are very not pleasant at all. So you're jamming away in your tube amp, and all of a sudden you're getting like this great saturation. You know what I mean?
Uh-huh.
So that's kind of the magic of tubes, and while they're still sticking around. And let's try and do this for a second. So that's the basics of like why a tube is better than, in my opinion, than solid state, because of soft clipping, and just the transparency when you're playing it. You feel better. It feels different.
Okay.
On some level, a good tube amp at first will almost make you sound like a bad guitar player, because you can't, like, the mistakes are just like ringing like a bell, just like coming out everywhere. You know what I mean?
Yeah.
So it's like just a totally different experience.
Well, as a bad guitar player, maybe that's why I don't play that loud in the first place. Uh, getting back to the schematic,
Yeah.
I might actually need like a little lesson on how to read that.
Yeah.
Just so you know, my dumb head is in the lower left hand portion of the screen. So everything like center right. Oh, cool. So the speakers
Okay.
over on the right hand side. Is this something that you read left to right?
Yeah, I generally lead left to right. That's usually how they're written.
Uh huh.
So this would be speaker, right?
Uh huh.
And this is going to be your input for your guitar.
Okay.
This is your power supply. So why don't we start with the power supply? This is your wall voltage, your 120 volts coming in. That's your ground. Here's your AC. That's a fuse. It's really important to have the proper fuse. This doesn't print the fuse amount. It's 3 amps, I believe. But having the wrong fuse can cause a lot of damage if there's a short. If you're blowing fuses, the amp needs servicing. Changing the fuses endlessly isn't going to do anything.
Okay.
So really important. That's your on-off switch right here. And then when it's on, this is your power transformer. And what that does is doing a couple different things. It's taking your 120 volts AC, and it's breaking it down into 6.3 volts for your filaments, because tubes need to be hot in order to operate. So you just have like a light bulb, you have a filament voltage. So if none of your tubes are lighting up, but maybe your pilot light's on or something, and you could have a problem with your filament line. So that's filament voltage. Each tube has its own filament. And then over here, you're getting about, on this amp, you probably have about 450 volts DC here, and maybe 500 volts AC. So your 120, it's stepped up to like 500 volts roughly. And then it's converted from AC to DC through this bridge rectifier. And now you have your DC voltage for the rest of the amp.
Patrick, can you move the clipboard to your left just a little bit? Awesome. Yeah. Thank you.
Sure. So now you have voltage here. It's not smooth. We've rectified it, but this is where we need filter caps to smooth the rectified DC to pure DC.
So if just to stop you really quick, when you say it's not smooth, does that mean that like if you were to throw it on the oscilloscope, you'd have like some kind of weird pattern, or what is?
Exactly. So AC voltage looks like a sine wave. DC voltage looks straight, but really poorly regulated DC kind of looks like this, like almost like a triangle. So that's usually indication you have a filter capacitor issue, and you can hear it. It'll have like a hum. And changing filter caps is a common repair because they're called electrolytic capacitors. They have a shelf life. Even capacitors today, if you change filter capacitors, you're probably looking at 20, 25 years before failure. Um, and it's funny, vintage amps, they'll come in from the 50s and the filter capacitors are still fine. So you debate whether to change them or not. You don't want somebody on tour, you know, having problems and also possibly damaging the amplifier. So generally those old caps, filter caps, they're going to change them out. Um, but it is funny that often the older components seem to last better than the new replacements. I've been doing this 20 years, and I'm finding I'm changing capacitors that I've changed 20 years ago. They've already at shelf. It's kind of funny.
So is that speaking of fetishizing things? Are filter caps the type of thing that people get nerdy about, or is that just kind of a nuts and bolts part of the amp that is kind of just make it work?
Yeah, filter caps are little nuts and bolts. People get crazy about coupling caps,
Uh huh.
and there's some truth. I think you can hear a difference in sound when you change the filter caps. Your amp will sound different when you get it back.
Uh huh.
uh, After changing your coupling caps. These are coupling caps here.
Okay.
The issue with that is, though, what happens in time is that they drift, and they tend to drift up, which means that the amp will get bassier and lose treble with age often. Sometimes it's the other way around.
Uh huh.
Also, these can start leaking DC and cause all kinds of problems. And then you're used to the amp sounding a certain way, so you're used to how it plays and feels and sounds. And then you bring it in for servicing, and if those caps are changed, now it sounds different. It probably sounds closer to how it sounded new back in the day. So it's not so much that, oh, they don't make capacitors the way they used to. It's a little more of that you're putting in the proper value and that the
So
older capacitors have drifted. When you change coupling caps, you're definitely going to hear a small change in tone.
uh huh.
And generally, that's not necessarily because of the type of capacitor. There's a whole snake oil thing with capacitors. Usually, that has more to do with you're putting in a capacitor that has the proper value, because components drift with age.
So
Capacitors, resistors, they drift with age.
so a lot of times, like what I do in guitar repair is I really have to get on the front end of managing customer expectations. How do you let a customer know that this needs to be done and expect some change in the sound of the amp that you've come to know over time?
Yeah, I'm pretty good at mentioning that. And we have to do a lot of change components where the sound's really going to change, like coupling caps, changing tubes. You're going to want to mention that, hey, your amp's a little bit dark. It hasn't been serviced in 40 years. It's dark, and we're going to change these components, and it's going to be closer to how it was originally. So it might have more highs. That might be a good thing for you. It might not be a good thing for you, but just expect that it's going to be a little bit different.
Uh-huh.
Often, you're changing these components. It's not like a night and day thing. Like, oh my God, it sounds. How did I ever play it before? So it's usually more subtle, but you can hear it, and
Okay.
so I just manage the expectations that way.
Cool. So I guess going back to the power supply, we should probably finish that circuit, correct?
Yeah. So I think we were getting into how we have power that's rectified here. We have our
Mm-hmm.
one in, that is our power transformer. That's a bridge rectifier. I'll say a lot of people discuss SAG, and a big part of SAG is going to be right here in how you're rectifying the AC to DC. So these are just diodes. These are four diodes set up in a bridge rectifier. Um, Old school way. This is 60s, but 40s, 50s. You had tube rectifiers, and there's still new amps manufactured with tube rectifiers. But
Mm-hmm.
tube rectifiers have a very big voltage drop, where as you're playing it, even at idle, you might have a 25-volt voltage drop on that tube. And then as you're playing it and playing it louder and louder, that drop goes up. So you might now have a 50-volt voltage drop, and it's swinging all over the place as you're playing it. So it creates a different sound and a different feel. People call it sag, you know, gives it more of a compressed sound as opposed to the solid state diodes, which has a very fast attack. Um, you know, personally, I kind of tend to most amps. I like the tube rectifiers; they sound a little better, but
Hmm.
it's subjective. It's really subjective.
So you actually like what is referred to as SAG, correct?
Yeah, I do. In guitar amps, I generally like SAG.
Okay.
Yeah.
It's just so the rectifier is that is basically just changing AC to DC, right?
Yeah,
That's
correct.
and so those diodes are kind of around in a square there. What's happening that changes AC to DC in that how does the current come in as AC and leave as DC?
Yeah, well, it's a little harder to show with the four diodes. If it was what's called full wave, it's a little easier to explain. But
Uh-huh.
basically, a diode only lets electricity flow one way.
Oh, okay.
And because this is AC, you have it swinging, up, down, up, down, up,
Uh-huh.
down. And it's out of phase on this side, up, down, up, down, up, down. So on an upswing, this will let electricity flow one way, and then it flows one way on the upswing here. So generally,
Oh.
it's not really like a switch, but you can kind of think of it like, because they're only letting it flow one way, you're just kind of capturing that upswing.
Okay.
And then that's why without the filter caps, it's not real DC. It's kind of choppy. You have this like choppy, almost like triangle DC. And
Because
then,
it's switching on and off.
yeah, exactly, exactly. And then you put in the rectify up the filter capacitors, and that smooths it out to direct current, where it's just straight, smooth DC.
Okay. So what are the I don't know if it's getting into the weeds too much, but what is it the filter caps are doing to smooth that out kind of from the
Well, filter caps act kind of like a little battery, where they'll actually store the charge.
Oh, okay.
They'll get charged up, and then as the voltage starts swinging down, the capacitor will discharge, where it just kind of levels it out. So it's like quickly like pulsating, you know, as the voltage goes down, the capacitor will discharge it so that it smooths it.
So when you turn your amp on and there's that little kind of delay before you can actually start making a racket, is that what's going on? Is those caps are actually kind of filling up or what?
Usually that's filament, where tubes need time to warm up.
Oh, okay.
So that's usually what's happening there,
Okay.
that delay.
So caps actually fill, they charge pretty fast then.
Yeah, lightning fast. Yeah.
Okay. So okay, so down there you got the so what's happening there? Part of it's DC, and then what's happening with the filaments? What's
Yeah, so normally filaments are AC. It's real simple. I like to think of it just like railroad tracks, where you have your 6.3 volts. So you have
mhm.
120 in, and it's dropped to 6.3 AC. And it's just like little light bulbs. It's really no different than that. Each tube has its own filament and takes a couple seconds to heat up. The plate and cathode of the tube need to be hot in order for the electrons to flow.
Okay.
So you're just heating it, and it's independent. There's no audio in the filament. There's
There's
nothing happening.
all that is just making the light bulb happening, huh?
Yeah,
Okay.
exactly.
So so we got that hot and we got DC coming out.
Hmm.
And do we move up to the next part then? And
Yeah, yeah. I'd like to. I have a highlighter here. We can kind of follow like where your guitar signal will actually go. So this is your input. Like this amp has two input jacks.
uh-huh.
You can plug your guitar into here, and you have a very small signal coming out of those
That's
pickups.
that's just your puny little like whatever your pickup
Yeah,
is sending out, and that's like in what millivolts or
yeah. It's very low. Yeah, if you have some pedals and you're really cranking, it can get up. It doesn't get up to like even like half a volt. It's small, so you need a lot of gain to really bring that up where we can hear it.
and what is the definition of gain? I guess I don't even really know what gain means. You're taking small voltage and turning it into big
Yeah,
voltage or
yeah, exactly.
okay.
Increasing voltage. Yeah.
Because gain kind of like in like kind of guitar amp knob terminology is kind of synonymous with distortion, isn't it? And
Exactly, and it's different than volume. You know what I mean? Like you can have a lot of gain and not a lot of volume. It would just be distorted.
uh
You know, um, wattage and eliciting power is different than just gain.
okay,
A preamp is really a voltage amplifier where we're taking this really small voltage out of the pickup and bringing it up to, let's say, 50 volts. But now we need to propel it to speakers. And that's where the power supply and really the power tubes come in.
okay.
So your power amplifier is what's really going to give you that current to take that voltage and really push it through, an output transformer and a speaker.
Okay, so going back to the input of the guitar, so that comes in, and then where does the DC that we saw in the power supply, where does that come
Yeah,
in? I guess.
that's a great question. So if you look at the top here, where they wrote A,
Uh huh.
the DC comes in from the top through what's called a plate resistor, and then it goes here to the plate of the tube. So this might be, let's say 200 volts DC, right? Now, these other components are kind of setting up the circuit. This capacitor is blocking some low end. This is a grid leak resistor. That kind of just needs to be there to set it up. Doesn't really affect the tone. This is kind of setting up how hard the tube's going to work. Cathode resistor, cathode capacitor. So we have a gain stage here, a voltage gain stage, where 200 volts DC, you only have like 1 volt DC here, and we're going to have a very small signal come into the grid of the tube,
Uh huh.
and a very large signal coming out of the output. And the output is right here. This is your output. So input,
Uh huh.
output.
Oh, okay. So what's kind of the magic inside the tube that's taking that DC and kind of translating the I assume that the signal coming in from the guitar is in some kind of like small wave.
Mm-hmm.
Is that AC or is that DC coming
That's
from the guitar?
that's AC.
Okay.
In fact, in a sense, all music is going to be AC because DC is just constant. It's just
Yeah.
if you put a DC to a speaker, it just pulsates the speaker and just stays there, stuck out or stuck in. There's no sound.
Oh, yeah, yeah, yeah.
AC is going to be movement. Sound is movement.
Okay.
So what we're hearing is always AC.
So you've got AC coming in from the guitar, and then you've got DC coming into the tube, and then but it's amplifying the AC and sending AC out the output. Is that
That's exactly right. And what's really cool is that you actually have, it's kind of hard to imagine, but you can have AC voltage riding on DC. So we'll draw that first stage real quick, okay?
Can you move the clipboard? Yeah, there you go.
Yeah. So this is the input, and then this is the output. And we already said, well, this is the plate. We have 200 volts DC here, and we might have 10 volts AC riding on it. So we have, 210 on the peaks, and below it, 190 if we have a swing. So, well, actually, no. If it's 10 volt swing, it would be 205 and 195. Sorry. But you actually could have on straight DC voltage your music riding on that, whatever the signal is.
And what's happening there? The DC somehow with the AC riding on it is actually amplifying the AC signal. It's juicing it or something, or
Yeah, that happens inside the tube.
uh-huh.
So as your small voltage comes into that grid of the tube, extra electrons are knocked off this cathode and are attracted to that DC, that high voltage DC. Electrons are just attracted, and they like stick to your small signal. So that's why here, okay, we have 200 volts DC.
Oh.
We also have this new impregnated AC on top of it.
Oh,
So
okay.
so we have the bigger signal now.
So in essence, what you have is on the wire coming out. There's both AC and DC, but
Yeah.
they're kind of like they're destined to kind of do independent things. I would
Yes.
guess.
That takes us to the next component and kind of what we talked about with coupling caps. The purpose of this capacitor here is a capacitor will block DC and let AC go by. So as our
Ah,
200 volts DC is sitting here and our nice guitar tone sitting here, that capacitor just blocks the DC. So over here, we have 0 volts DC and we only have the AC.
okay.
Now, if this cap starts to fail, it might leak, let's say 5 volts DC into the rest of the circuit. And that can cause, all kinds of weird issues. One, the pot will sound scratchy. And you can clean it out, but it never goes away. Every time you turn that knob, you hear this kind of scratchiness.
Uh huh.
Often you have leaky coupling capacitors.
And what's happening in that capacitor that the DC is causing scratchiness? Is it just too much
It just
voltage
breaks
for the?
down with age. They literally just break down with age.
Uh huh.
They actually just dry out inside, and you start getting there's an insulating material that starts to break down. Often it's just paper, and it breaks down and dries out, and then that DC voltage just starts getting through to the other side.
Cool.
Yeah. So now we have our first stage, our first preamp stage, and we have nice guitar tone coming through our volume pot right here.
So this is where so the volume pot. This is where we've got full voltage, and this is the first potentiometer that's saying perhaps we don't want to play it at maximum volume all the time. And,
Yeah, yeah, that's exactly right. That's a good way of looking at it. That all the volume, it's not increasing anything. It's just attenuating full voltage because
okay.
you have everything right here at your disposal. So we're just attenuating that down to either 0 or a listening level. And then out from the volume pot, it goes into our tone control, which is this pot here. So all this is doing with these components is it's cutting highs. It's not boosting anything. It's not boosting lows or boosting highs. You're just cutting high end.
Just throwing it in the garbage.
Throwing it in the garbage. And then it goes to your next stage. So now you have your playing volume and your tone into the next tube, which is the next stage. And on this, it's this is kind of unusual circuit. This is a phase inverter, and the reason we have a phase inverter is because we have 2 power tubes. In a push-pull circuit, you have 2 power tubes or 4 power tubes, and you actually have to take that signal and run them 180 degrees out of phase. If you look at a champ, it's a little simpler because you have 1 power tube and you don't need a phase inverter. You just take your guitar signal and you amplify it through the 1 tube. The problem with that is if you want more volume than 1 tube can handle, well, what are you supposed to do? So you have to create a push-pull circuit and add a phase inverter.
So by push-pull circuit, do you mean we're talking a push-pull pot on a guitar, or is this different terminology?
It's different. Yeah, it's different. So if I could draw this out, we have our nice guitar signal, and we're actually going to split it in 180 degrees. So when this is going up, this is going down. When this is going down, that's going up.
Okay.
We have a 180 degrees out of phase signal into our power tubes. That's what these are here. These are 2 6L6 power tubes.
So when you say out of phase, does that mean like one, like if you're playing the AC signal, or the AC signal is coming through, one of it's taking the top and one of it's taking the bottom of the wave, or?
Exactly. Yeah.
Okay.
And that's on the extreme peak. So on the extreme peak, you're taking, there's at a point where it's kind of takes it both. because it's a constantly moving the signal. You know what I mean? We're just kind of thinking about it in a snapshot,
Uh-huh.
but it's constantly moving. So yeah, a simplified way is that they're out of phase. So you're taking a top half in one tube and a bottom half in another tube, amplifying it, and then it all comes together here in the output transformer.
So when you say push pull, it's not like it's not like one power tube is pushing the speaker out and the other power tube is pulling the speaker back in. It's combining at the end to do its thing, or how
Yeah, they combine at the end. So let's just say this tube can put out 25 watts,
uh-huh.
and this tube can put out 25 watts. Your end result could be you have 50 watts driving power here.
Okay.
So if you were to add like a Fender Twin or like a 100-watt Marshall, you have 4 power tubes.
Uh-huh.
So it would be 2 of them. These 2 would be basically in parallel.
Okay.
These would be in parallel. You can add more. You can add, 3. There's high watts out there with 3. So you have 6 total tubes. And you just keep stacking them up to get more wattage.
So you say this is kind of unusual in that it's a push pull. Would they ever just have the power tubes lined up in series, or is that silliness?
It's kind of silly. You see it in some esoteric like hi-fi designs and some other weird designs. It kind of creates problems with impedances and transformer matching and all that. Most amps do have a phase inverter. What I said about this one, it's just a little bit unusual the way it's drawn.
Oh, okay.
It's usually like this signal here goes here and then it splits here. It's just a little bit, they kind of do a wacky way of doing it. But yeah, the idea of a phase inverter is pretty standard anytime that you have more than one power tube. And the reason to have more than one power tube is just for more wattage.
So you can make a bigger racket is what it sounds like.
Exactly. And then that kind of goes back into the idea of sag too, because, you have all of this power. Well, how beefy is your power supply? Do you have an adequate power transformer? Do you have adequate filter capacitors? Are you running a tube rectifier? So as you start cranking it, the voltage drops and the amp kind of sags, So it's kind of all works together. Kind of the magic of a good sounding tube amp is like, a little bit of power tube distortion, a little bit of preamp distortion, a little bit of sag, a little bit of output transformer distortion. There's not like one magic thing that's happening. It's kind of the way it all kind of fits together.
Uh-huh.
Like a gumbo.
So, people get paid for they spend a lot of money on kind of boutique amps. Is that where the magic is? Is people really get into the weeds on all of these different components and try to, figure out how to make them work together in a pleasing way, or is it, I can't imagine. I mean, was Fender putting that much energy into testing and really dialing in?
No.
Or were they just trying to make a racket? And
they were trying to make a racket. Fender had some brilliant engineering and brilliant simplicity. And I think one of the reasons why all the Fenders sound good, when we're talking Tweed 50s, up into 70s Silverface, was just good engineering, good components, and the simplicity. I've heard some good boutique amps, but a lot of them, there's so many things happening that it's not my thing,
Uh-huh.
I think some of the more classic vintage amps just do sound better, make you a better player too.
Do they?
I think so, yeah.
Well, I need to start spending some money if it's that simple.
Yeah.
So they were I guess getting back to Fender, like, were they actually thinking about it, or were they just grabbing the parts they had and doing the best they could with
they were doing the best they could, and they were grabbing whatever they could, often cheap components.
Uh-huh.
However, cheap components in 1963 are pretty fucking amazing. I mean, if you think about it, that's all they had then. So it was used in medical devices. It was used in, test equipment. And so everything was just, very high quality regarding electronics and tube amps, because that's all they had. Now you're putting in a capacitor that really is made for a computer or something.
Yeah.
So it's just, I think too, like the simplicity of those circuits, you just can't like deny how beautiful and simple a lot of this stuff is. I mean, this is such a simple circuit, but this thing screams.
Yeah.
In fact, while we're talking, I'll hook up a few wires and I'll bang a cord through it. It just screams, and it's just pure overtone distortion.
So I think we've gone through the circuit. Can we actually look at it and
Yeah,
practice on the amp and see like where them electrons are hiding out at?
yeah, yeah. So I have the chassis turned upside down. So we'll start over here. The power transformer is right here, and the wires come up. That's your on-off switch. That's your fuse. These are your power tubes over here. So I guess we're looking at it a little bit backwards. So we go to this side. This is your preamp.
Uh-huh.
Those are your two preamp tubes. These are the coupling capacitors. Volume pot, tone pot, input jacks are here behind this plate.
Uh-huh.
This is your
Am I seeing a few more resistors in there than
yeah.
we're on the schematic, or
Probably not.
probably not?
Yeah. But they changed. These circuits were changed constantly too. Filter capacitor. Those are your diodes here. If I can get in a little closer. And
Oh, so that's your rectifier in there with the
yep,
so that long thing. So that's a diode.
yep, 4 diodes. 1, 2, 3, 4.
How do you tell the difference between a diode and a resistor?
Diodes have a band on them. They have one band.
Oh, okay.
Resistors have a color code. Hold on, I get a little more light in here. Boom.
So okay. So the schematic called for 4 filter caps. Do I see 4 filter caps there, or is there just one on there?
That's a good question. I see 2. See?
Oh, is it 2?
Yeah.
Okay. They're just not on the schematic. Were they in series, or?
Let's take a look here. Yeah, well, it's funny actually. 1, 2, 3, 4, 5.
5.
But 2 of them are in. So these 2 are in parallel, and that's kind of silly. So they add in parallel. Somebody drew this. This isn't like a factory schematic.
Oh, okay.
So yeah, that's pretty strange. And look, this guy wrote 4 microfarads. Yeah, I think we only have 2 here.
So, do you think what we're looking at in the amp is closer to what the factory schematic would have been then?
Yeah, this is pretty much original.
Okay.
Somebody changed a few capacitors out. These are not original. This is a yeah, that's not even that's a cathode capacitor. And here's the power tubes here. So one thing about this amp is interesting. It's called cathode biased. That's kind of a hip boutique term right now for people who want kind of the Class A sound.
Uh-huh.
Even though
can I back you up one?
Yeah.
I've heard that term biasing quite a bit. I have no idea what it means. What does it mean to bias an amp?
Well, I like to tell people, I like car analogies.
Uh-huh.
It's like setting the idle on the car.
Oh, okay.
If you want to run your amp kind of hot and you're going to run those tubes kind of hot, there's tonal benefits to that, but you're also decreasing tube life. So when you're setting a bias on a tube, you're basically setting the point over which it operates. So if it's biased too cold, it's going to sound awful and it's going to clip. You're not going to be able to even get enough voltage out where you get a clean sine wave. And that's also one of the things in the beginning when we put up a sine wave, We want to see a clean sine wave. If it's not biased right, you won't get a clean sine wave. So as you increase the bias and you get a nice clean sine wave, you want to see, okay, where am I at now? So I'm at the midpoint, right? That's kind of where you want to operate, right there in that midpoint. If you go too high, it could damage the tubes, it can damage the power supply, it can give you different problems, but it also could sound amazing. So,
Yeah,
you know,
for a very short time.
yeah. So you certainly you have some discretion. Okay, I'm on the midpoint now. Do I want to turn up a little bit? You know, maybe I want to have it run at 70%. You know what I mean? I really want to crank it up. And you have some leeway to it. And it depends really what kind of amp. Each amp's different. Each tube's different. Each tube manufacturer is different. You know, so certain manufacturers like 7591s, I don't know if I want them to run too hot because the amp will fail and the person will be right back. You know, so there is a certain amount of like experience.
So
And
so when you're setting the bias, are you changing a component? Are you turning a dial, or how are you changing the
yeah,
bias?
in this amp, I would actually have to change a component.
Okay.
And I'll show you here on the schematic which component. So this component right here,
Uh huh.
and it's funny, it says 270 and then he crossed it off and wrote 200. So um, mine says I have a 200, so that's okay. So that resistor here is the cathode bias resistor, which is setting the bias of both of these power tubes.
Okay.
If I wanted to run this hotter or colder, I would have to change that out.
So that's just basically taking some amount, almost like a tone control, and just throwing it away, and not letting the tubes use it, or is that how does that work?
Um, well, it's sort of it's more of just like a mathematical formula
Oh, okay.
of you're creating a voltage drop here because this is ground, this is zero.
Uh huh.
So as these tubes start engaging, you're creating a voltage, you're creating a bias voltage. Okay, we'll say minus 32 volts. Um, so that's one way of biasing tubes in a cathode biased amp. In a lot of like Fenders, if you think of like a Fender Deluxe something, or a Fender Twin or Pro Reverb Marshalls, they use a fixed bias method where this resistor isn't even here. It goes straight to ground, and you apply your bias voltage actually right here after your coupling capacitors. So you'll be putting in voltage here this way. It's a different way of doing it. They both have their pros and cons. And then often with fixed bias amps, there's actually a pot you can adjust.
Okay. And with
And,
that would be on the inside of the amp, not for rookies to be
correct.
messing
Yeah,
around with on the outside.
exactly. So you're just going to adjust a pot and you're going to set your bias that way. Um,
Cool.
so some amps, you can change power tubes yourself. Some you don't want to. And with a cathode biased amp like this is, and a lot of the little amps are, you have some discretion and you can probably change your power tubes yourself. With a fixed bias amp, it's not recommended because it's probably not going to be set right and you can have problems.
You could hurt your amp. It sounds like.
Yeah. And also, if you're having amp trouble, most repairs, I'm not changing tubes. You know, more than half repairs, it's not a tube.
Yeah.
You know, and then let's say it is a tube. Let's say this tube shorts out, and then this tube it will take out this resistor. So this resistor opens up. So now you buy a set of tubes and you put it in, and it still doesn't work. You know, so it's really good if you're having problems. Just bring it to a technician that you trust and you have a relationship with.
Yeah.
You know,
Or spend years of your life learning it.
you
Either
can
way.
do.
Um, well, I think it would be interesting. So the Supro is in for problems, correct, or is it in for servicing?
No, this is just mine. I just pulled it this morning.
Okay.
Yeah.
So I think it would be interesting to take, you know, let me just say, pretend like it was mine, and I brought it into you and I said, Jesus, I keep putting fuses in and it keeps popping them and it refuses to make a racket. Kind of your usual suspects of troubleshooting kind of look like in that Supro amp.
Yeah. So first thing, if you're blowing fuses, you're pulling excessive current. So you're going to be want to looking. You're not looking at a preamp problem. You're looking at a power supply problem. Or you're looking at a power tube problem. Something that can really draw a lot of current, or a shorted transformer, which is rare. Is rare. So if this were your amp and you were popping fuses, first thing I'd probably check is the rectifier diodes.
Yeah.
One of those shorts, it's just going to keep popping fuses. The second thing I would check is probably make sure you don't have shorted power tubes. Third thing, make sure you don't have shorted filter capacitors. And then fourth and fifth would be the output and power transformers.
So on the going back to those individually, like on the rectifier, like I mean, would you get a visual like? Would there be something visual that would that you would
Some,
look for?
Sometimes, usually no. Usually I would just use my meter.
You would get
But
a meter out and put it on
yeah,
there and make sure you don't have a failed component.
exactly. I'd be looking for the short, or maybe if it's not as short, there'd be a really low resistance, like 100 ohms or 200 ohms, between what's called your B plus, which is, basically your output of your rectifier here.
Uh huh.
You would have very low resistance here if you're popping fuses.
Okay.
You should have high resistance here. If you're popping fuses, there's something, I would start with this rectifier. I would start with the power tubes, capacitors, filter capacitors, and shorted power transformer.
So you would just go through would you just systematically start at the beginning of the schematic and work left to right until you found what it was, or are there?
I would start dead center. I would start with the rectifier.
Yeah.
I would start right here at your B plus set, and I would see if there's a short. And if there is, I would maybe disconnect this. You can disconnect this wire and very quickly see, okay, is it happening over here, this point, or is it happening over here? And I could figure it out in 2 minutes.
Cool.
What would be hard is if it's intermittent, if it's like, well, and this happens, like after an hour and a half, it blows a fuse. And then, and then you put in a new fuse, and then I got through 3 gigs, and then it happened again. So now you're spending, you could potentially be spending a lot of time trying to figure out where that short is,
Because it's happening in just kind of a random moment, like a intermittent failure, almost like a shoelace that's on the verge of breaking, but not quite.
Yeah, it's like, I like car analogies. It's like our car is in the shop for the 4th time, and it's like every 20 miles, like she would just break down, and they're like, I don't know, it's not throwing codes, it's fine, and then we've been driving it all day, and then we pick it up, break down. So intermittent problems could definitely, eat up your time. So with that kind of stuff, that's why with my bench here, I have so much space, because I'll actually have an amp that I'm working on, and I might have an amp that I'm burning in, for an intermittent problem. So I'll let that thing run all day with test equipment up to it. And if it doesn't act up, well, then the next day it's just turn it on, just burn it in, wait for the problem to show up.
Wow. Is there any time that you would like maybe overstress it to get a component to fail, or is that just nonsense?
Yeah, I definitely overstress it. I would hook it to the dummy load so I wouldn't be blowing my ears out, and I would pump it with a lot of signal and really stress it, and that tends to have the problem.
Cool. So what's kind of like the craziest? How far into the weeds have you ever gone on one where you're just like kind of racking your head, and then it was some kind of crazy solution that took like all of your mental faculties to bring to bear on it?
Well, you can get weird problems. I mean, the 2 things that could be weird would be like radio interference.
Mm-hmm.
Like every once in a while, you start getting a radio station,
Yeah.
You know, guitar amps are basically like they're like radio receivers for audio, you know. So if you're close to like, you know, a cell tower or, you know, an AM station or something, especially in New York, there's a lot of RF flowing around. You know, you can get weird stuff that just starts coming through your, you know, like a ghost just coming through.
Uh-huh.
So those problems could be tricky. And then the other thing that's tricky is you get weird like coupling problems where like two components that are it's like next to each other like start like mutually like coupled. So like anytime you have a wire, let's say this is a wire,
Mm-hmm.
and you have DC going through it, AC, there's a little bit of magnetism that's kind of coming out. So you can actually have components that one morning they just decide they're like cross talking, you know, and you just move them half an inch away from each other and the problems, you know, goes away. So those can really drive you nuts.
Yeah.
Like weird problems where it's just mutually coupled, um, radio interference, sometimes moisture. Sometimes you can get like if it's just really humid out, you can get a lot of moisture in an amp, and it's like just kind of crackly and noisy, and you know, well, okay, it's a tube, okay, it's not a tube. It's you know, you're trying everything, and it's not going away, and you sit there with the heat gun for a minute, and you dry the thing out, and then you know it goes away. So the moisture.
Interesting. Yeah,
Um,
because a lot of those old components are probably, you know, just like instruments. Like they're pretty are they susceptible to temperature and humidity
yeah,
changes? Like because you're talking about like things that are like the way they work is having things almost very close together but almost touching. Like it
yeah,
seems like that would be fraught with
yeah,
peril for expansion and contraction
ex-
from.
exactly, exactly.
So trying to think, have we covered just about everything? Is there anything you want to show off on the? Do you want to make a? Do you want to do a ham radio demonstration? Do you want to make a call or anything? Or
You know, my antennas are down because we're doing tree work,
uh huh.
but I'll give you a tour and talk about some stuff.
Yeah.
Yeah,
Can you run me through what it would be like to make a call, or
definitely. That's a great
is
idea.
it called a call?
A CQ call, CQ,
Uh huh.
which I guess that comes from back in the days of Morse code, and I seek you, CQ, CQ. So you make a CQ call where you're just trying to find someone to shoot the shit with. Yeah. So yeah, this is
So this is command central for you and talking to people around the world and including the people on the space station, from what I understand.
yes, I've done that with my buddy. He's all into that. He's contacted. That's more his thing,
Uh huh.
uh, but he's contacted the space station, um, and I was with him. Yeah, that was pretty cool.
Uh huh.
Uh,
What exactly do you say to the space station? You just kind of like, hey, space, all right?
it was all through the computer, just like a message. You just get like a verification that you made contact.
Oh, okay.
Yeah, yeah.
So they're not like, yeah, we're up here drinking Tang, you know,
No,
like,
no. It was pretty quick. Yeah, it was pretty quick.
huh?
And
Well,
what?
they're pretty serious people up there, I imagine.
Yeah, their time's limited. They're pretty serious. Yeah, but that you know you make up a good point about it's kind of fascinating about amateur radio because different frequencies do different things in different times of the year and different times of sunspot activity.
Uh huh.
So, um, with amateur radio, you need a license. You need to pass a test to get a license. And I like to do a lot of what's called HF, which is definitely high frequency, even though it's very, very low frequency.
Uh huh.
So, like AM, real low frequencies. And that is really kind of propagates, transmits, and travels based on sunspot activity. So, it's pretty wild that, you know, you'll actually know, like, you'll actually can check, like, how much solar activity is coming from the sun. Oh, we have 4 sunspots and we have all this magnetism coming toward the Earth. You know, in 24 hours that certain frequencies will called open up and you'll be able to talk, you know, halfway around the world, you know.
Wow.
and then it just goes away, and then you're maybe only talk 100 miles on that frequency, and then oh, there's another sunspot. 4 o'clock tomorrow, go to 7.29 megahertz and see what you can come up with. And
So it's a real art form.
yeah,
It's not like you just you have equipment and you turn it on and it's like Mr. Microphone or a CB
yeah,
radio or something like
yeah.
that.
This is I do have a lot of CBs here. So a citizens band, you don't need a license, and that's generally just for local talk.
Oh, those are
You can't
CBs?
get, yeah, these are vintage CBs.
Oh my god.
One I love. These were made in Brooklyn back in the '60s. These are fantastic sounding CBs.
I'm,
So I actually have a third one, and this one I modified for amateur radio bands.
uh,
So that was one of my COVID. That was my first COVID project,
uh,
actually. Was
I'm
to
so
set,
overwhelmed with knobs that I didn't recognize the CBs from
yeah,
when I was a kid. Have you ever listened to
yeah.
that song "Teddy Bear" by Red Sovine? You know that
No,
song? Oh,
no.
it's a song where a kid winds up a handicapped kid winds up inviting a bunch of truckers over to his house, and
Uh,
it's portrayed as a good thing in the song. Um,
right.
yeah, it's it's quite the listen.
Yeah.
I'll have to send that to you. So
My my has started a CB club up here,
uh
and I think next weekend there's like a picnic for
yeah.
CBers. So I'm gonna check that out. We have the Hudson Valley CB Club. It's a Facebook page, and all these old guys who haven't been forever are like getting on the air and you know rag chewing.
So are these old like truckers that are enthusiasts about CBs from their days of trucking,
I,
or is it?
I don't even think they're truckers. I think they're just guys who were into it back in the day. Maybe
Yeah,
now they're retired. Time, you know.
because I mean, it was so part of the culture there for a second. Like trucker culture became really mainstream there. You had Smokey and the
Yeah,
Bandit and Convoy and all
yeah,
that stuff. Like I just remember, like I wanted a CB for Christmas.
yeah,
Like
yeah. Well, it's coming back. I mean, I think even more so, amateur radio has a huge spike right now because of all the stuff that's going on. People want like a way to communicate. You know, not to get political, but when Obama got elected, far right people went crazy and all got their amateur license. And then when Trump got elected, far left people went crazy and got their amateur
uh
license
huh.
because it's the end times. We're all going to need to talk to each other. So now with COVID and people are just more and more people keep getting into the hobby.
Yeah. It's a. I've watched a fair amount of Doomsday Preppers, and I gotta say, I haven't seen a lot of ham radios on there. It's kind of a weird prep, but
Yeah,
maybe it makes sense.
yeah,
But
survivalists, always like preppers and survivalists, and you know. But I will tell you something interesting. We're talking about the sun and sunspots. Um, Look up the Carrington effect of 1859. The sun is on these kind of cycles, and when sunspot activity really starts heating up again, there's going to be lots of communication issues and lots of issues with solid state equipment. So all this tube equipment just loves it. I'll be fine. I'm not going to have any problems. But when there's solar flares start up and electrical grids start going down, and you start losing all your data, um,
you're
I'm
gonna
going to
be
be
you're gonna be sitting pretty.
yeah. I mean, I can raise my rates, actually make a living.
Did so getting back to what you were mentioning, was that the one where Morse code wires actually caught on fire? It was like
Yeah,
it was so intense. And
yeah, yep,
I'd heard a rumor that we kind of scoffed at the Soviet Union for not switching to microprocessors in their military, but they were actually sticking with the tubes precisely for kind of guarding against EMP stuff, right?
yes, exactly. it could happen anytime, but most likely it's going to happen when the sun activity picks back up.
Yeah.
And there's different cycles. It's like 11-year cycle within a 300-year cycle, within like 11,000-year cycle, and all
Uh-huh.
this. Like in our lifetime, we've been just in the low of the low
Uh-huh.
since we've had all this technology. So we don't even know what it's like to live in a time when there's really a lot of sunspot activity.
Are consumer electronics with microprocessors, are they at all, is that at all factored in being shielded from solar activity, or is it just not even a concern?
Yeah, I don't think it's a concern. Yeah.
Boy, that's some that's some short-sighted stuff
Yeah.
right there.
I think the real issue is going to be like power grids where you have long transmission lines.
Yeah.
And once the power grids go down, you know, what are you going to do? You're going to start rebuilding them, and then it's just, they're going to get zapped again. So,
Uh-huh.
yeah.
Do you think that makes an argument for Elon Musk's kind of having your own kind of battery cell in your house, or is that, do you think those battery cells would be affected? Like, would you just like completely destroy? Would something like that completely destroy your own like kind of like solar farming or?
I don't know. I don't follow him that much. People always ask me about him, and I just like, hey, he's married to that girl that's in the band, Grimes. Like, I don't know. But yeah, I think if he's trying to do something where you're off the power grid and have your own power, your own battery cell, it's probably a good idea.
It seems like a decent idea. Like I don't know much about it.
Yeah.
So you want to flip some levers and show me what
Yeah.
like if you were trying to talk to somebody in Australia would look like?
Yeah. Yeah. I'll show you right now.
What's the furthest? Just out of curiosity, what's the furthest you've ever raised a signal from?
Let's see. Italy. I get into Europe pretty easy, so a couple contacts in Italy, the UK. I think I had New Zealand. That's probably, yeah. I had New Zealand
That's
contact. Yeah.
that's I think is that as far as you can get before it starts getting closer again.
Correct. Yeah, because then you're halfway around the world. So if I were to fire up and want to make a contact, my main operating position is this 50s transmitter.
This is a transmitter.
Yeah, this is a transmitter. This is only a 40-watt transmitter, but I have an amplifier here to bring it up to a couple hundred watts. So then I would kick that on. And so this doesn't receive. So I would use one of my receivers. I'd probably use this guy and fire that up. And then I have to get them synced up. So if I wanted to transmit on, 7.2 megahertz, I would have to set this up for transmitting at that frequency, and then this set up for receiving at that frequency. And then this was made for Morse code only, which I don't do. So I kind of have it hacked with this modulator that I built. So then I would fire this up, and this actually converts my voice into just like a guitar amplifier, converts it into 60 watts audio, goes to a modulation transformer, and that is tapped into this power supply. So now I'm transmitting audio. So I don't know if you got all that, but tell you what I'll do, because I actually built this at Main Drag, and this sat for 6 months in the shop, and I hacked it so that we would listen to music through it, but it's mono. But what I'll do, I should turn that off, is, oh yeah, that's the radio. Hold on. Turn that off. Okay. And then I would just, this is KD2 MKT, CQ, CQDX, KD2 MKT on 7.29 megahertz. And you would wait for a response.
That's cool.
That's basically, yeah.
How long does it take before somebody responds to you? And what if like three people try to respond to you? Like, is it like a
That yeah, you kind of have to keep order. You have to try to because they'll tell you your call sign. Everybody gets a call sign. You say, okay, I hear W7RZ the loudest. Go ahead, and then you'd have that contact, and then you'd go on to the other ones. So you kind of just have to like keep law and order because people get they start piling on. It's called pile on, and. But most people like obey the rules. It's an older crowd. It's very respectful usually.
yeah? There's a barrier to entry that seems like it would preclude idiots from
Yeah.
getting involved in it.
Well, there's kind of like CB people and ham radio people kind of hate each other,
Oh, really?
and I kind of do both worlds.
Uh
But
huh.
there's like a whole like oh, you do CB, I won't talk to you.
Really?
Yeah.
Uh huh. Well, the ham radio is definitely like. I mean, you got more knobs, so maybe there's
Yeah.
a knob envy thing happening there.
More knobs, more frequencies, and more chances to make contacts into different parts of the world.
Yeah. I mean, the range on CBs isn't tremendous. I mean, it's like within a
Yeah.
town, right? Like you're,
It's terrible. Yeah.
huh?
Joe Walsh is a big ham, and I've never spoke with him, but everybody I know is like, yeah, I was talking to Joe last night.
Joe Walsh, the Eagle.
Yep,
Oh
yep.
wow, he's
He's
he. I thought he's actually struggled to speak now, but so. Oh, he
I,
every
yeah.
time I've seen him in an interview, it seems like he has a hard time talking in general. But
Oh, jeez,
what?
I didn't know that. Yeah, he's
Well, I think he's enjoyed some substances
yeah,
in his time. But so you want to talk about you you're dipping into the world of high end audio as well too,
yeah,
right?
yeah.
Do you got anything you can show us on that
Sure.
front?
I'll flip this camera around. Let me turn off my 2,000 volt amplifier here. This is a prototype I've been working on. We just got the faceplates in, and there are some mistakes. We have to redo them, but so this is just taped on. But this is a 120 watt mono amplifier for audio for your home, for listening to music, not for a guitar
Uh huh.
or anything like that. Not for contacting the space station. It's for very high end. I've been working on this for years. But once COVID happened, I really had the time to dive in pretty good. So you would need two, one for right channel, one for left channel. And yeah, the results are fantastic. I'm really psyched with how it turned out. It really sounds good. I mean, and I don't even have amazing speakers. Like I'm going to have to upgrade my speakers just to really like keep tweaking this.
Uh huh.
These tubes here are rectifiers. We were talking about rectifiers before. These aren't common. This is a rare mercury vapor rectifier. That's why it has that glow.
That is cool looking.
Yeah. So that's what's going on there. It's actually, as it's rectifying, it's igniting the gas inside.
So is that a new tube or an old tube?
These are from the 40s. Yeah, this is old. Not something you would normally see for sure.
So as a business model, is it sustainable to be sourcing the tubes like that, or are you going to really have to like kind of hoard them?
Yeah, you kind of have to hoard them. I mean, I don't plan on selling a lot, so I can probably get the tubes that I need. These are not common either, but you can get them. I handpicked. I probably tried. 40 different tubes when I went through designing this. Maybe 5 rectifiers, 10 preamp tubes, 10, 15. I think I had 15 phase inverter tubes, and I did it by sound. I just kept changing it and changing it on these amplifiers here, which is kind of the same circuit. And then I just kind of like when you get your eyes checked and which lens looks best.
Mm-hmm.
I just notes on which tubes I thought sounded the best, and then I designed a whole amp around the tubes that I want to try and hear as the best sounding, and it really came out good. I'm really happy with the performance. I mean, it's
Well,
pretty
I
good.
mean, Anthony said he was able. Was Anthony actually able to kind of be around one while it was going, or did you just send him videos of it?
Just on a phone, yeah. I just sent him
Yeah,
video.
yeah.
Yeah,
Well, I'll tell you what. He sent me that video on the phone, and I could tell even through a crappy set of iPhone speakers that something pretty incredible was happening there with the sound.
yeah,
Which
yeah. I'm pretty happy with the way it turned out. We just had the one last thing we just got on Thursday, the dial and the faceplate, and we just made an error when we were uploading it. This is supposed to be round, but it's square.
uh
So
huh.
this sits behind here. So this is my homage to radios. Is that as you're controlling the volume, you're actually going to be moving this dial.
Oh,
You know,
cool.
yeah.
So, is I mean those are rare tubes. Is there going to be a protective case around the tube area, or is it just freestanding?
It's freestanding. One thing you can do is you can actually operate this without the tubes. There's a switch in the back that will turn off the tube rectifiers, and now it's on solid state rectification.
Okay.
So if it's really making you nervous, maybe you have, because you actually have 500 volts sitting up here. If you got small kids or cats or something that makes you nervous, you can actually just pull these out and disable it.
Yeah.
Um, but you get different sound. Like we're talking about SAG, you get different sound qualities between using the tubes and using the diodes. So it's kind of a feature, but it's also kind of a safety issue. You
Yeah.
know, and there's mercury inside. You wouldn't want those to crack, and you'd actually get liquid mercury. You don't
Yeah.
want.
Yeah. Is so you said one of the tubes was rare on the right hand side. I think with the white cap as well. But are the remainder of the tubes fairly standard
Yeah,
fare?
they're fairly standard. These are new KT88s. You can get these. Fantastic power tube. Um, these were used in like 50s automobiles. These are a little rare, but you can get them. Locked tubes. Um, these were used in like small car stereos back in the day, and they're really good. They're cheaper. For old stock tubes, they're relatively cheap, and the performance is excellent. So, and they look cool. So that's kind of why I use them.
Well, cool. Is there anything else you think would be cool to share, or?
I'm just gonna. My battery's about to die, so I'm just gonna plug this in. Let's see. We didn't do. You like to do the whole open the drawers thing,
I
right?
do like to do open the drawers. What what kind of specialty? I mean, everybody knows about soldering pencils and multimeters and stuff. But are there any kind of specialty tools that it takes to really be
Yeah, I
to
mean,
get?
the main thing is going to be my meter. I use that in everything. So you need a good voltmeter. I have this Fluke here.
Mhm.
Uh, that's 99% of the time. It's actually even rare that I need an oscilloscope. I always have one going, but the time that I actually need one to troubleshoot is pretty rare. This is my digital oscilloscope, which I hate. Um, it's just too slow. My old analog one is the bomb. I use that all the time. Um,
Too slow, meaning the signal path is too slow, or
takes a
it's
second. It takes a second to actually see the waveform. Like every time you adjust it, the screen goes blank and it tries to
uh,
there's like a second and a half delay. It's not like a huge delay, like a second and a half to see the image.
yeah,
But
that's
I,
annoying though.
yeah, I can't deal with it. Most of my audio stuff's in Brooklyn, and a lot of this is radio stuff that you wouldn't really use in audio.
Uh,
Um, this is kind of cool for radio stuff. It's a radio signal generator. You can set the different frequency here. Um, this is a must if you're doing audio. Signal generator or a function generator, because you need to be able to make a sine wave or a square wave. That's my frequency, one kilohertz, and that's the most common when you're working with audio stuff. You're usually working with 1 kilohertz test tone.
so behind you is like you know, probably a lot of the blue drawers and stuff. Is that all full of caps and
Yeah. Well, I'll start with this. This is cool. This I got at Radio Shack. This was their display for parts. So I got these.
oh man,
And, these is knobs, coupling capacitors, and at Main Drag I have the identical cabinet and the identical components.
I like the nice big font on there.
Yeah, we custom did that. Kelly did that, and then we printed them out here at a local shop. And they're magnetized, so I can move them around.
Oh man.
Yeah, and they're rock solid cabinets, so it's like the best deal I ever got.
So, do you miss Radio Shack at all, or was it kind of useless at the time it was going out?
It was useless, but I still miss it.
Yeah.
You know, this is like machine screws and hardware. Especially if you're building, you need a lot of screws and stuff.
Yeah.
And I probably spent a couple $100 in McMaster car order and all this stuff. I did this
at least.
Porch.
Do you have any? Do you do any kind of inventory on that? Do you keep track of it digitally, or is it just kind of like you look in there and?
I have inventory on Lightspeed of all my parts.
Oh, you brought a copy of Lightspeed home?
Yeah, on my computer, my laptop here, I can see what I have. Cool. I'm probably due for updating it because I haven't adjusted it in a while. So it says, oh, I have 30 12AX7s and there's like one. So I do need to fix that. But
cool.
This is cool. This is for punches for making chassis.
So, pull that out. That's a for making holes in your sheet metal.
Yeah.
Oh man, I would think, like, it doesn't come up a lot, but I kind of want to see what's going on there.
Yeah, sure. Yeah, this is it here. They're really easy to use. You have to drill a pilot hole and then put the punch on.
Uh-huh.
And then the die here, you just
screw it together and
screw it hand tight, and then you ratchet it closed.
And then
perfect hole.
And perfect. Does it leave it burless, or do you have to go back and kind of clean it up?
It's almost always burless. Sometimes you have to take a little file or sandpaper, but it's almost always perfect if it's nice and sharp. Yeah.
What does that tool cost?
They're expensive. I think they're about $100 now.
Mm-hmm.
And they only make us so many sizes, and all the punches I needed for my amplifiers were weird sizes.
Yeah.
So to find used ones on eBay, it probably took a year to find all the sizes needed. It wasn't easy.
What's that tool called? Is it just a sheet metal punch or?
Yeah, radio punch, knockout punch.
Okay.
This one's really old. It comes in a.
What is that?
A punch.
Oh, a punch. Okay.
Yeah.
And that was the one that came off of eBay?
Yeah. I probably paid $40-$50 for these, used.
Uh-huh.
It's nothing really fancy in here, just a bunch of junk.
Some more meters, and the microphone I think is probably pretty important for a lot of the stuff that you do, right?
Exactly.
Do you also work on PAs? I mean, are tube amp PAs a thing, or is that?
There's a Fender one that sometimes comes in, and yeah, once in a while a tube PA will come in that I'll work on. Sure.
Like, do people fetishize the tube PAs like they do the tube guitar amps, or?
No, not really. I think with PA, you're probably better off staying away from tubes.
Yeah.
Actually. Yeah. So yeah, this is a pretty nice pellet stove, so I'm toasty warm.
Yeah.
In here, because that's the outside.
So you're not actually in underground, so you don't have to like mitigate humidity and.
I actually because 3 sides of the house are underground.
Okay.
So I run a dehumidifier, and it's pretty dry.
Do you have a sump pump down there, or is it?
Yeah. I don't have anything. And I've had water down here before, but it's pretty rare. It has to be really pouring for like a day.
Uh-huh.
For a little bit of water to get down here.
Huh. Cool.
Cool. I guess I'll do a quick of all these radios again, and then
Yeah,
yeah,
it's
a
good.
lot of my schools are in the city.
Yeah. Well, I think we got some good stuff here. Oh, what's that green lamp? I'm into lamps.
Oh yeah, I found this on the street in Brooklyn.
Of course.
Yeah,
People throw away the best stuff there, right? Or is
it's
it actually thrown away if somebody else walks along and picks it up? I don't know.
yeah, yeah. This is vintage. This is really I love this lamp.
Is that a vintage light bulb in there too, or
It's a new
yeah,
reproduction, and this the top half I replaced.
yeah?
You know,
It's just awesome though. Like it's
yeah.
like I was in one of my other interviews, I was lamenting the state of swing arm desk lamps. Like
Oh yeah,
it seems like it's just impossible to get anything that isn't just falls apart immediately.
yeah. It's a real problem. I mean, I probably went through like 3 shop lights at Main Drag before I finally just bought a vintage one.
Yeah, yeah,
I'm
those,
at 10, so I had to plug in, come over here and plug in.
yeah. Well, Pat, I think I'm going to let you get back to work, man. I really appreciate you taking the time to show me this stuff. This has been really awesome, and I think I can't imagine people aren't going to just love seeing this.
Yeah,
Thank you so much.
anytime, anytime. And we want to have classes down in Brooklyn at some point. So if people want to build an amp or take a class,
I
that's
think God, amp building like it really does seem like fun. I think for me especially, like I'm interested in it, and I think definitely hands on. Like looking at a tube while you're describing how the electrons are working in there. I think would just really cement the knowledge. Like
yeah,
because it's still. I mean, you got me on down the line with a little bit of knowledge there, but it still seems it's just a little bit of magic still involved in it in my brain. Like
yeah.
it still
There is
doesn't.
magic.
What's that?
There is magic. I'm convinced of it.
Yeah, it seems like it. It seems like it would be hard to explain it all just with little electrons floating around and things.
And I'll give you another reason why people should go tube and build a tube amp because it will last forever
Yeah,
and it could be serviced forever.
yeah. I know. I know. Dave was getting into the solid state stuff, and boy, it did not look fun. To
Mm,
it did it it didn't look like I don't know. Like it looked like basically you gotta I don't know what like
yeah.
would it be like a full blown electrical engineering degree and
No, not that. Not
not
that.
that bad.
Yeah. It's just hard to get parts. If you buy a solid state amp, then you get a couple years out of it. Once it goes, you move on.
You move on.
Yeah. I had a quick story. I'll tell you what. I'll end with a quick story. Um, a guy probably about 3 years ago brought an amp into Main Drag that he bought the day he graduated high school in 1959. So he graduated high school, and his dad took him immediately to like Sam Ash, and he bought this Ampeg Jet. And it was never he used it, and it was never brought in for service until he walked in with a guitar, a beautiful Gretsch, and this Ampeg amp, and he walked in, and used it from 1959 to now. And we did, I don't even think the bill was $200, some caps, some general stuff. And now he's good for another 40 years. You know what I mean? It's like
Yeah.
it's generational.
Well, I think like getting back to that swing arm amp stuff, like
Yeah,
yeah, it's something about that era they built things without thinking about like how are we going to make more money by making these things fail, like
right.
so.
Yeah. More technicians, more old stuff, but more technicians. That sounds
Isn't that something? I like that world better, I think.
good. Yeah. It's environmentally better,
Yeah.
you know.
All right, Pat. Well, I really appreciate you taking the time.
Of course. Of
All right,
course.
take care. Hey,
All right. Thank you.